Okay, this is Dr. Williamson. Oops. One of the first things you're going to do with your sample is you're going to measure the absorption of your sample at many different wavelengths at about 400 nanometers or so to about 750 nanometers. Here I have 300 to 700 nanometers, but you're going to measure its absorption from about 400 to 700 or so, where the absorption is the ratio of the outgoing light intensity divided by the incoming light intensity, and the minus log of that, given a fixed concentration and a fixed path length. And you're going to get what's called an absorption spectrum. And it's going to show how well your molecule that you're studying absorbs at 400 nanometers, 405 nanometers, 410 nanometers, all the way up at all these different wavelengths up until the highest wavelength that you measure. In this example, it looks like I measured from about 400 nanometers to 600 nanometers. Yours, you're going to measure 400 to 700. One of the things that you want to get from your absorption spectrum is called lambda max, which is this thing right there, lambda max. And the way you get lambda max is you plot your absorption spectrum, and then you find the highest absorption value on your graph, and then you find the wavelength of light that gives you your highest absorption value. Okay, so in this case, my highest absorption value looks like it's about maybe 0.85 or 0.9 or so absorption. And the wavelength associated with that looks like it's just a little bit over 500 nanometers. If I'd made my graph bigger, I might get something like lambda max. I might get lambda max here. Right? I might get my lambda max is maybe 505 nanometers. And the reason why I want to know lambda max is for later absorption studies of that molecule. This is the wavelength of light that's the best wavelength for studying that molecule. Generally, the best wavelength of light for studying that molecule. Okay, that's the gist of it. Okay, there's more. I've left out some stuff. Those of you that are really into atomic absorption spectroscopy, this isn't intended for you, right? This is just a real basic overview. Okay, so just want you guys to know that. And oh, by the way, absorbance doesn't have any units. Whatever units I had, I naught has the same units. And when I divide I by I naught, the units cancel out. So we'll say absorbance, and we'll put parentheses ARB for arbitrary units. And one of the things we use this for is to find lambda max, which is the wavelength of light. That is the wavelength that my molecule is most sensitive to. Therefore, it's the best wavelength of light to study my molecule with. Okay, all right, I hope that helps.